What's going on, everyone? My name is Johnny Bandon, and I'm your CCNA instructor for this CCNA video series. And in this video, we're going to go over quality of service and actually do some configuration. So we just have some simple stuff we're going to go over. And really what this is trying to do is get you a little bit familiar with the modular QoS Cisco CLI or known as MQC. And then we're going to go over some show commands. And then a very important part of this lab is going to be running that Wireshark capture so you can see your IP precedents or DCP markings leaving the interface that we're going to apply our QoS policy on. So pretty cool. Another just real easy lab. You see a simple network diagram here. We have two networks connected to one router. And that router is going to be doing all of our QoS markings, queuings, shaping, and policing. So that being said, let's go ahead and get started. So I'm going to start this like I do every other video. For all of our paid users, this lab is available to you already pre-configured with all the prerequisites, baseline, IP addressing, all that, as well as all the iOSs we're going to use in here. R1, to get this working, to actually get me to send traffic to the internet, and even G, I have this, what it's called like a management device or network device. It's just a NAT cloud. It allows my devices in EVE-NG to actually use the internal connection from like my ESXi host here, because I'm running the VM on ESXi. It actually allows them to access my network, this 192.168.1 network, kind of acting as like a bridge. So what I got to do here as R1 is I just create a static route going this way. I create dynamic NAT or PAT overload, and I say these are my inside addresses, this is my outside, and this enables this IP address here to actually reach the internet. So when we apply our QoS, you're actually going to see these PCs actually is going to do an HTTP request and ICMP. So awesome. With that being said, for my non-paid viewers, this course is entirely free on YouTube. So let me get my face out of the way. And every baseline, every instruction, even the course solutions I'm going to put up here are going to be in this GitLab, which should be in the description below if you're viewing on YouTube. And these are going to have the instructions. So I'm going to open up this QoS lab here, which has all of our instructions. And then I'm going to go ahead and move this off to the right, to the monitor you can't see. And we're going to go over this lab now. All right, make this my face a little bit smaller because it's all about the CLI now, right? Not looking at me. So we're going to go into our steps. So number one, turn on all devices. I did that by coming over here to more actions, start all nodes. Then paste baseline from GitLab. So again, on our GitLab at the root folder, CCNA video course, we have baselines that you can copy and paste. Only thing you got to do is change that host name. Bring that off to the monitor you can't see. And nodes verify our connectivity. So it's console into R1. It's called console into this PC. And we're just going to verify that we can actually reach out to the internet. So I'm bringing up Secure CRT now. I'm just getting it like zoomed in. Okay. So R1, we have that baseline configured. So I can see that my baseline's in there correctly. Now we just check IP addressing. Okay. DCP, haven't got an IP address yet. So good thing we're verifying this IP addressing. Let me just zoom out of this a little bit. There we go. Okay. So R1, we're going to come in here. We're going to go into interface 800. I'm just going to shut it and no shut. Try to re-engage that DCP message. So depending what kind of network management device you place in here, you have a bunch. You have this cloud, you have management cloud 0. These ones enable DCP. With this one, you got to set a static IP that's a part of the home network, you know, that VM network. This one, it should be DHCP, but let's just check to see if we got one yet. That's okay if we don't. We can just set a static IP, so 192.168.1.160. No shut this. And then we can do our ping tests. So right now I'm just going to make sure I can ping out to the default gateway. Looks like I can't. Okay. I think I know how to fix this. We're up. I set a good IP address. What I'm going to do here is just change this to cloud 0. Again, I'm not going to go too deep into that. This lab is about doing QoS. But essentially what that allows me to do is not do DHCP to that management cloud. I wonder what is going on here. Let me check this again. It's up. Let me go into interface 00. Type in shut. No shut. Do ping 192.168.1.1. It's always good when we get a little extra troubleshooting in our labs, right? That's what I get for restarting it. I should have just kept it working when I tested it before I started recording. All right, so what we're going to do here is, I think maybe Nat's messing this up a little bit. It's just another evangelism, I like to call it. So I'm going to do a quick Wireshark capture on here. See what I got going on. See if my ICMP messages are even making it out. Okay. See, it doesn't even see ICMP messages coming across. So what we're going to do here is just, we're going to quit this. R1, what I'm going to do is go into eth00, type in no IPNAT outside, shut, do reload. Yes, confirm that reload. Let's go ahead and delete this. Stop this R1. We're going to add that network again, but this time I'm just going to do this management cloud. Connect it up to eth00. Start this bad boy up. And then I'm going to pause the video and we'll come back. Okay, we're back. So sorry about that, guys. I hate when I have to do troubleshooting when we're focusing on a technology. I probably won't edit it out of the video because it's good to see, right? Essentially, all I had to do was just restart everything, and now we're able to ping. So from R1, I have a static default route going out towards that network management cloud. I have enabled NAT, and you can see here I can ping Google even if I source it from eth01, which is the voice network. And I can also do it even if I source those pings from eth02, which is our sales department. So now let's go ahead and jump into the QoS part of this video, right? So again, I have my instructions over here on the screen, and I'm on my GitLab under section 6 labs, QoS labs. So you can see it right there. All right. Okay. So now we're going to move on to step 4. So now we're going to classify the HTTP traffic, and then we're going to mark it with an AF43 bit, and then set the bandwidth to 20%, and we're going to place it in a priority queue. So how do we do that? So first thing we're going to do is create a class map, and we're going to give it a name. So we're just going to name it HTTP. This is case sensitive when we have to refer to this class map again. And then since I just want to match HTTP traffic, what I'm going to do here is do match protocol HTTP. Boom, and then we're done. And we'll go ahead and set that bit to mark it in our policy map. So then it says set the bandwidth to 20% and place in a priority queue. So what I'm going to do here for the instructions is every time it says for me to mark and set bandwidth and do queuing, I am going to wait until we get to the policy map. And what I'm going to do first is go ahead and classify everything. So next thing I'm going to classify is going to be class map, SSH, that's just the name. And I'm going to match the SSH protocol. And then I'm going to classify YouTube. Yes, at this iOS, we can even match YouTube as a protocol. Pretty cool, right? Kind of getting into that more content aware. We could even match, if we wanted to, we could even match Facebook traffic. Pretty cool, right? Or FaceTime. I think that's pretty cool stuff. Okay, but moving on. Now let's classify ICMP. So we're going to match protocol, ICMP, which is going to be our pings. And then we're going to classify VoIP traffic. So let's think about this one. I think that what we should do, since this is our voice traffic on this subnet, let's create an ACL. So we're going to do access list 30, permit IP, right? Or let's just actually just put the IP address in and the wildcard mask. So now we made an ACL to define what subnet we want to classify. And now we go into our actual class map creation. So we're going to call this one VoIP as well. And we're going to do match access group and then give that ACL number 30. So now we're going to match VoIP traffic based on the subnet it's going to be sourced from. And now let's get into our policy map. So this policy map is now going to have all that queuing and shaping and policing for all those classifications we just made, all those data classifications we just made. Now we're going to actually do something with them under this policy map. So this policy map is where we're going to set the DHCP markings. It's where we're going to set the bandwidth and the queuing. So we're going to call this policy map user experience. We're going to define a class. So what we're going to do here is say, okay, we want to set a DCP marking and bandwidth on our HTTP classification. Okay, and that is like case sensitive and name sensitive. So if I didn't have a class name HTTP, it wouldn't let me. So for HTTP, what are we doing? We're marking it with an AF43 bit. So that's going to be set IP DHCP AF43. And then we're going to set the bandwidth to 20% and place it in a priority queue. So for this, what we do is priority. We're going to give it a percent. And then we give a percentage of our bandwidth, 20. So if we actually go ahead and look at this interface, show interface 00, our bandwidth is 10,000 kilobits. So whatever 20% of that is, I'm bad at math. I think it's 2,000 kilobits is what we're going to get, right? Because we got to go off what's configured for the bandwidth of that interface. And then we're going to exit. Then we're going to do our next class of our next marking and our next queuing and shaping and policing, right? If we had to police. So this is going to be our SSH. So class SSH. We're going to set the IP DCP bit to AF12. And we're going to set the bandwidth to 20% and place it in a weighted fair queue. So let me show you something. So this command, fair queue, is going to do weighted fair queuing. And it's going to be class based because we're doing this command under a policy map under a specific class. So this command will only be applied to this class, right? It won't be applied to any other class except this one right here, class SSH. Well, look at that. Not allowed without bandwidth or shape feature. So this is saying like, hey, we don't know this queue size because you haven't set the bandwidth or shaping it. So if we were to do shape and we were to do, I don't know, average percent and this committed rate 20, that would work. And then we could do fair queue. But this time we're just going to do bandwidth. So what this is going to do is set a bandwidth, say, hey, this queue should be this big, or you should queue packets once traffic coming into this that matches this class goes beyond 20% of the bandwidth, put it in the queue. So I think we said 20% as well. And then we can do that command fair queue and we're good to go. Next, we're going to do class YouTube. This one says set it with AF bit 32. So it's going to be set IP DCP bit AF32. And then I think we're going to do the priority for this one too. Priority percent 40%. Then ICMP traffic. We're going to do a little faster here because we're just kind of repeating. ICMP is going to be an IP precedent bit. So we're going to do set IP precedence 2. Class selector 2. And then this one's going to be bandwidth 10%. Priority bandwidth. So LLQ, low latency queuing, percent 10. And then we're going to do VoIP traffic. So class VoIP. we're doing an EF bit. So that's going to be set IP DCP, the expedited forwarding bit. That's the best, right, priority we have as far as DCP goes. And then we're also going to do priority percent of 5. Okay. Now, let's check out our policy here. So if we try to do show policy map, this is just going to show us what we configured. Can anyone guess what's missing here though? Really any metrics in our default class. Remember, there is a default class that catches everything else, that if we didn't do any configuration, it's just going to be FIFO queuing and it's just going to send first in, first out, best effort. If we wanted to change that, we would have to go back into our policy map. I think we called it user experience. And we have to do class default, and then we can set a bandwidth. And typically this would just be like everything else. So I haven't done the math, but remaining percent. Oops. So we could do the remaining percent. You got to do the math though, but I'll just do 10% here. Just leave it, right? And then if we do show policy map, let's see if it shows up. It does. So now we're saying, okay, here we go. We actually defined our default. If it didn't, it would have just done the defaults, which is nothing, right? Just everything else. But we could also we could have set an IP precedence, DCP bit, and we also could have done queuing on this as well. We could have done fair queuing or whatever the case may be. So now, this is the command. When we want to see actual metrics, see if our policy maps are actually getting hits, if it's actually being applied correctly. But you see, we got nothing. And that's because the final step is actually applying this policy map with the command service policy. And we want to go outbound. We want to do all this to traffic leaving our customer edge. Output, and then user experience. All right. Now, when we run this command, here's what we should see. And I'm going to zoom out a little bit for you. So you see that it's going to actually give us like stats for everything. Obviously, we have no packets coming in. So what this shows us, like, okay, this gets 4,000 kilobits. This gets 10%. It kind of shows us and groups it out and shows it nicely to us. Then this match any is going to be that logic where it's like anything that matches this. Where the all, if you don't match this access group, nope, that's it, right? And if we added any other match criteria, you'd have to match that access group and like a protocol to actually get police shaped or queued or whatever, get traffic manipulated in this class map. So that being said, let's actually go to our PC here and let's do some commands. So let's try our ping. So let's ping 8.8.8.8. Okay, that's when we're going to get a hit there. When actually, let me do a Wireshark capture. So let's make sure that we actually are doing this correctly and our markings are getting put on that IP header. Okay, so let me do that ping again. Let me try to SSH somewhere. See if that matches our SSH. Okay, we'll still get a connection there. And then let's try to do HTTP. So we can actually do this to try to simulate some HTTP traffic. Test.cfg. And that's not going to do anything, but we can test HTTP traffic. And then I can't simulate YouTube or VoIP traffic. But that's good enough. Let's go see if we have some hits in our policies. So we actually do show policy map, and we could just do, we only want to, let's do section HTTP. So you see this, we have some hits. And we can see that we have our burst bytes, right? We can see what's going on here. It's pretty cool. It says packets were marked. Let's see if we got the other hits. Let's do SSH. Got some hits there. Let's do ICMP. And I'm just filtering this out. Awesome. Now let's go back here and do like DNS. Let's send a DNS request. Okay, sorry about that. And let's see our default. Let's see class default. And we got some hits there as well. Awesome. So it looks like we're doing our QoS policy that we employed. Now let's go see if those packets actually got marked. So we're going to come in here to Wireshark. Come down here. Let's go all the way back up to that traffic we were sending. ICMP. So what we want to look at here, we'll do that from ours. So we got to do the correct source. If we look in that IP header, we can see here in the TOS bit or byte, look at that. We are applying our class selector 2, which is what we want on an ICMP. If we come down, let's do this TCP connection. It was SSH. Look at that. We have those connections as well. So I think this is pretty cool, guys. Seeing how we actually are putting that DCP bit. Sorry, there you go. That back there didn't have it. But actually putting that DCP bit on there. We're actually marketing. We're giving that assured forwarding a 12. And then you come down here to HTTP. We can see here. There we go with that DCP bit being marked. So pretty dope. We can actually see this happening. You can see in the IP header just kind of validating what we should know or what we know should be happening. All right. So that's going to be it for this QoS lab. If you guys enjoyed it, please subscribe to the channel. If you want some more, if you want some direct Q&A with me, being a part of our Discord, having access to our test center if you're in the Fort Bragg area, which everyone does, but if you want some more information on our training, in-person or online virtual training, please make sure to check out our website below and subscribe to this channel, and I hope you enjoyed.